Hello guys, I'm back. If you are a chemical process engineer that wants to work with plant design, stay with me because today I will share with you 5 questions that must be answered when you start a project. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design and responsible for the INPROCESS Booster training program. These questions not necessarily will come up for you in this sequence that I will show to you right now. But if you are dealing with a project from scratch or you are developing a new customer that requires a solution from your company, most probably you will need to answer them. And do not make sense to you start your process simulation on Aspen High-Seas or in other process simulation software if you don't have at least some of these questions answered. So based on that, I prepared this list and I hope you like it. One of the first questions to be answered when you start a new project is, what are the system of units? It seems to be a thumb question, but it isn't, because when we are dealing with liquids or when we are dealing with gases, it can do a lot of differences. Imagine that in a globalized way or in a global world, you can be in India and doing projects for Europe or South America, or you can be in Brazil like I am and doing projects for Asia, North America, Europe, and etc. And each country usually has its own units, official system of units. For instance, in America, most often they use the imperial numbers, imperial system of units. In Brazil, we use the international system of units, so I am familiar with meters, kilogram, Celsius degree, and others derivatives from this kind of system of units. So today I was in a meeting with a supplier from US and I asked him about the weather, how it was the weather in the USA, and he told me that the weather was around 32 Fahrenheit. And Fahrenheit is not my usual way of thinking. I think in Celsius degree. So I took some time to do the conversion in my mind that it is around 0 Celsius degree. And it was easy to do this kind of conversion because 32 Fahrenheit is well known. 32, 212 Fahrenheit are the limits of the 0 and 100 Celsius degree. So it was easier to convert that. But if you need to deal with another system of units, it's important that you set your process simulation according to that, in order that you avoid to do this kind of a conversation into your mind or in spreadsheets. Every time that you start a new project, try to use the system of units of your customer, of your client, and not the one that you are familiar with. Why it's better to proceed this way? It's better to proceed this way because the contract will be made based on the customer requirements, and you need to guarantee the customer requirements. Some companies, for instance, use bar-G as the standard system of units, while other companies uses kgf per centimeter square. They are quite the same, but depending on how much is the value, as you increase the values, the difference between both of them gets larger. So it's important to you use the system of units of your customer, or eventually use the worst case. But to make sure that everything will be okay, use of your customer. Another thing that is important to understand is that when we talk about volume flow, especially for gases that are compressible fluids, the basis of temperature and pressure matters a lot. Today, I had a discussion with 2 customers in different meetings. During the morning, we were discussing about the delivery of biomethane flow to a pipeline, and I make sure that the basis for the flow measurement is 20 Celsius degree and 1 atm. This is the basis for natural gas measurement in Brazil. In other countries like the Europe, if you are using the international system of units, it could be, or it will probably be 0 Celsius degree and 1 atm. And if you go to the US, eventually your system, your basis of measurement for the natural gas will be 60 Fahrenheit and 14.7 psi. So it's important to you make sure what is the basis for the measurement of gases. And another customer, another client I was discussing and it was at the afternoon, we were talking about flow of gases because he shared a spreadsheet with a volume, and he said to me that it was addressed as 20 Celsius degree and 1 atm. But when we go straight to the point, if I ask a plant to deliver a gas in normal cubic meter per hour, and I buy this plant from Europe, for instance, the temperature basis will be 0 Celsius degree. And why temperature matters too much for the measurement of gases? It matters a lot because as compressible fluids, when you change the temperature of water, you change the mass density, and depending on the mass density for the same flow of mass, you will have different values of volume. For instance, using 0 Celsius degree or 20 Celsius degree, you can have around 7% of differences in the measurement. So imagine that you design a system and you are selling a gas for the customer, and because you misunderstood on the basis of temperature, you are delivering less than the customer expects, or you are measuring more than in fact you are delivering for the customer. That is a kind of issues that you don't want to deal with in a contract. You want to deliver what the customer needs, and based on that, the profits, the revenues for your company will be okay. Some other kinds of issues that you can have with system of units is when you have short ton and you have metric ton. When you do the relationship between pounds and kilogram, it's not an exact number. So sometimes people use short ton to represent the conversion of pounds to thousand of kilograms. And depending on how you design your plant based on short ton or tons, that can lead to a misunderstanding, and again, you can have troubles in the contract. And another thing that I like to have explicitly in the contract is related to pressure. Because if for any reason you read in the contract that it is 10 bar to deliver to the customer, and you design your system thinking that 10 bar is 10 bar absolute, you will have the 9 bar or around that. It depends on the altitude of your plant. You will deliver your pressure 1 bar below that it is considered. Most often, the measurement of pressure in the field is based on manometric devices. So you will have the manometric the measurement of your pressure. But operations sometimes don't understand that. The businessmen that do the contract sometimes don't understand that how important is to differentiate the manometric from the absolute. So it's your duty to make sure that the system of units that are being considered of the contract is correct or not. I'm talking to you about this because currently I am a chemical process engineer. I work with plant design, but assist the business team very close. I work in the same department of the business. And my duty as the chemical process engineer, as the expert in the engineering, is to make sure that the technical parts of the contract is matching or not, if it makes sense or not. For instance, another example that I can give you, I received a contract where the customer wants a range of operations in terms of pressure of only 0.2 bar differences, and the higher limit of the pressure where we shouldn't not achieve in any way was just 0.2 bar above the normal operation conditions. And even I would like to add a pressure safety device to guarantee a mechanical guarantee that the overpressure would not have any kind of damage in the system. I couldn't do that because, as you must know, when you add a pressure safety device, if it is a standard pressure safety valve, you start leaking the valve with 90% of its set points. Or in other words, you must have 10% of safety margin from this PSV set point to make sure that you will not start leaking your pressure relief device. If you use pilot PSV, the safety margin can decrease, but most often you will use a standard PSV, so because of that you need to have at least 10% margin from the PSV set point. Based on that, it is very, very important when you start a new project that you define the system of units and make sure that everything is very clear, not only for your company and your engineering department, but also for the customer, because this way you will prevent having any kind of misunderstanding. We already talked about system of units, and now let's talk about product specification. Again, it seems to be a thumb question, but it isn't, because sometimes the customer or the client didn't know what they really want. And when we starting a new project, you must understand what are the requirements of the customer, what they really want from us. And talking about plan design, process design, we start our project from the product specification. I need to understand what are the characteristics of the fluid in terms of volume, pressure, temperature, composition, and any other characteristics that is very, very important to the client or to be in compliance in the contract, because this way I will be able to select the technology available to achieve that. If I needed to do dehydration of a natural gas, for instance, I have many ways to do that. I can use desiccant, I can use absorber, I can use membrane technology, and the best technology to be applied in a project depends on all of this information. Sometimes you will find customer certifications that do not specify all the requirements for a fluid. For instance, they are worried about the flow and pressure, and there is no specification for the temperature, or eventually you will find a requirement for main components of your fluid and will not talk about the contaminants. So every time that you face this kind of situation, use the good sense, because higher pressure, high temperature can change the material that you use in your project, and that can lead for increase in capex, increase in opex, and you don't want that in your project. So in case that you are not sure about the customer requirements, officially ask them for an answer, because this way you can prevent any misunderstanding, and when you prevent misunderstanding in a project, it is very, very good for you and for the company. We talked about the system of units, we talked about the product specification, and now let's talk about the raw material characteristics. It's very, very important that you have a good understanding of the raw material characteristics. Again, it is not a thumb question, because why are you able to develop a process if you don't know the product specification and the raw material characteristics? For instance, I always like to share with you my personal experience, and it is based on real project. And as much as possible, I share this kind of information or this kind of knowledge with my students in my INPROCESS Booster training program. Today, again, I had a meeting with a customer, and he wants that we deliver to them a biomethane based on its specification. And to produce biomethane, I need to have the raw material, and the raw material in this case is a biogas. But in his specification, it was a request for proposal that he sent for the market. They sent to the market, and based on that, their expectation is to receive some quotations asking to them how much could be this to deliver to them. So company A will offer a solution, company B will offer a solution, the same one or different kind of solution, and all of that will be based on the product specification that was available in their technical specification they provided to us, but also based on the raw material characteristics, because the responsibility of supplying biogas for the upgrading plant was from the customer. And in his technical specification, there was the volume, and based on that, I was able to verify the size of the technology that should be applied to upgrading of the biogas, but I didn't have information related to the biogas composition, the pressure available, the temperature available, how much H2S was in the gas, or how much saturated was the gas, if it was saturated or not. Taking this case as example, let's suppose that I have 100 ppm of H2S in my biogas. I will choose one kind of technology for removing the H2S from the stream. But if it has 1,200 ppm, the technology used for that can be another. Or if I have 12,000 ppm of H2S, instead of using adsorbent or activated carbon, I would need to use a biological system to remove the H2S. So it's very, very important that you have all definition or all the characteristics of your raw material. Sometimes it is not easy, because if you are dealing with a stream or raw material that is not a standard material like a pure component, when you have pure components in your stream, it's easier you add that to your process simulation, and the INPROCESS will give you all the characteristics of the fluid based on the fluid package that you choose. Sometimes the process simulation software don't have the component that you are using in your process, and that leads to the use of material safety data sheet. You will need to have the access to literature or some lab information and etc. So although it seems to be obvious that you must have the raw material characteristics to starting doing your project, sometimes you don't have this kind of information, and you must look for that. Another question that must be answered when you start a new project is, what are the utilities available to your process, or what are the utilities available in the location? If you are not familiar with the term utilities, utilities are everything that you use to produce your product, but it's not part of your product. For instance, when you have the reactions, you are doing polypropylene, you have the cooling of the jacket of the reactor, you need a cooling system to do that. You can use cooling water, or you can use other refrigerant, and these are utilities. You need electricity to run your process, to run electrical equipment, to run electrical devices, control valves or PLCs and etc. So that are also a utility. Or you you have a refinery and you need to add energy for the reboiler, and eventually you can use steam, low pressure steam, to add the energy for your boiler. So your main purpose is to do the refining of the petroleum and have its fractions, gasoline, naphtha, and etc. But you use another source or another stream to support you on reaching that. So this way you have the utility. There are many other utilities that you can consider. For instance, instrument air, depending on your process. You can have also demineralized water, and there are many other utilities. And you need to be aware which kind of utilities are available for your project. For instance, if you need to install an oxygen plant and there is no industrial or potable water available in the location, or if it is too expensive to be used as a utility, you cannot consider a cooling water system, an open tower to do that. You will need, for instance, to consider using air coolers to do that, because the air coolers will use the air as cooling medium, and the water that recirculates in the system will be in a closed loop, and you will not waste, or you will not lose the water during the process. And that is totally different when you are using an open cooling tower, because the effects of cooling the water is based on the asperging of air and the exchanging of temperature and mass, and it's normal to have the losses of water, and you need to do a makeup of water to refresh or to refill the bases of your cooling water system. So if you don't have water available, you cannot consider that kind of solution. Let me give you another example. Imagine that you need to add a pretreatment natural gas system in a desert location and where you don't have electricity going there. So eventually you will need to have power to run the compressor or to run the pumps that are needed to do the dehydration of the gas, for instance. So based on that, you will need to have a motor generator. You need to get part of the gas to produce electricity at the location, and that electricity will run your equipment. That kind of information impacts how you design the plant, how you do the plant design. So that's why when we are starting a new project, we need to map all the utilities available in the customer, if it is the customer responsibility, or at least in the location if I need to get from the concessionary or other supplier. And all of these questions are very important to be answered when you're starting a new project, but probably from these 5 ones that I have shared to you, the most important one in my point of view is this: what are the deliverables that must be issued in the project? You that wants to be a chemical process engineer working with plant design, you must understand that the role of the chemical process engineer is to solve problem based on the issue of engineering deliverables. What I mean by that? You will not perform a process simulation by the process simulation itself. You will get the results of the process simulation to produce the heat and material balance, to develop the pipe instrumentation diagram, to represent or to get the main equipment and represent that in a process flow diagram, and many others documentation. So when you starting a new project, and it depends if it's a small project, only upgrade in your existing plant, or if it is a big industry like a polypropylene plant or another chemical plant, you need to understand from your project manager which are the deliverables that must be issued. and why it is so important in plant design. It is important in plant design because the costs of engineering are based on man hours. And as much deliverables you have to issue in a project, more time you will need to develop them, and more expensive will be the engineering. In this case, we are talking about the chemical engineering. So for small projects, it's common that as less documentation as possible is issued is better for the project in terms of CapEx. I'm not talking about if it's wrong or right. I'm talking about the point of view of the stakeholder, because it's the stakeholder that pays your salary or that pays the fee for the company pays your salary. So make sure the deliverables that you need to issue, because based on that you will fill a sheet with the main hours to develop your project. And another thing that's important to know about the deliverables is if you work with operations. Sometimes what operations needs to comply with the requirements of the regulation is not something that the engineering department is to worry about, because the main worry of the engineering department is to build the plant, not necessarily comply with the regulations of the plant. That's in some cases requires a lot of information that is available but not necessarily registered. So if you work with operations and you know that a new project is starting your plant, and you know that there are requirements or regulations where you need to comply with some requirements, make sure that the person or the responsible for purchasing the service are asking for that kind of information. In Brazil, we have a legal requirement. It is the NR 13. It's very famous between us here in Brazil because it deals with pressure vessel, and sometimes the suppliers don't deliver the documentation issued specifically for this regulation. And once you purchase the service and once the equipment was delivered, to have this kind of documentation can be a tough task. So make sure that if something is important to your job in operations or in quality or etc., make sure that all the requirements are asked before purchasing the service. Once you purchase a service and you add more requirements for a contract, the chances are that you will expend much more money that you could expend if the requirements was asked before the contract assignment. Based on that, we have talked about system of units, product specification, raw material characteristics, utilities available, and deliverables to be issued in your plant design. So if you want to be a chemical process engineer and work with plant design, keep following my social media like YouTube, Telegram, LinkedIn, because there you will find much more content related to this. So this is it. My name is Jeferson Costa, and I'll see you soon in the next video. Bye-bye.